Hi friends, welcome to MX. Now in this video we are going to see about the entropies. That is how the second law of thermodynamics leads to an entropy. It will be useful for hints in the problem while solving. First, in entropy we are discussing about what is Clausius theorem. In this, it defines the cyclic integral of dq by dt. In this, for reversible cycle it is equal to 0. You can see the notations. And the cyclic integral of dq by dt for irreversible is less than 0. And entropy or entropy change, it is ds is the entropy change where it is greater than or equal to del q divided by t. And in this case of reversible it is equal to. And when the ds comes to the universe, it is equal to or greater than 0, where the terms are ds is change in entropy, del q is heat transfer, and T is termed to as absolute temperature. The things should be remained or entropy change in a reversible process is a point function and it is an exact differential, that will be an differentiable value, and it is extensive property, not an intensive one, for which the reversible adiabatic process is an isentropic process. But reverse is not always true. When a system is at equilibrium, the change in entropy will be 0. Now coming to Clausius inequality, in this it provides the criterion of reversibility and irreversibility of the cycles, for which the closed integral of dq by dt is lesser than or equal to 0. When it is equal to 0, the cycle is termed to as reversible. When it is less than 0, the cycle is termed to as irreversible or possibles 1. Greater than 0 is impossible, for which change in entropy of a system is why it's due to the heat transfer and internal irreversibility, that is the entropy generation. That is the difference of S2 minus S1 gives us del Q by T plus S generation, that is due to heat transfer and also due to internal reversibility. In this, entropy generation is a path function and it is always a positive value. Now, twin equation of entropy, it gives us TdS equal to du plus pdv, and rearranging the equations as u is termed to as h and substituting the values. That's the above equation are applicable for reversible and reversible process for open and closed system. And entropy change for finite body is given as del S equal to mc ln Tf by Ti. Now entropy change during phase change. Here del S equal to ml by T, where L is termed to be a latent heat of phase change and T is the saturation temperature, that is the freezing boiling point. In this case, we are dealing only with the phase change. In before case, we are dealing the phase change in finite bodies. And now entropy change for an ideal gas, that is state 1 and 2. You should remember the formulas, that S2 minus S1, that's routinely given as Cp ln V2 by V1 plus Cv ln P2 by P1. And in terms of temperature, that is T2 by T1 plus gas constants R and ln of V2 by V1, and the same as T2 by T1 minus, it comes the minus for pressure, ln of P2 by P1. What is the things to be known are change in specific entropy of a system will undergoes the isothermal process. It's by ideal gas, that is also represented by del S equal to Cp minus Cv, that's ln of V2 by V1. Also for isothermal process, change in specific energy, it's donated as del S equal to minus Cp minus Cv, that is a ln of P2 by P1. Now the slope of constant volume and constant pressure line is given as, you can see that curve where dt by ds at constant volume is T by Cv, that's a constant volume, and the specific volume. Now coming to specific pressure, dt by ds for P equal to T by Cp. Hope so friend, you understand what is entropy, and it will be very much useful for in solving the problems. If you like my videos, please subscribe and share. Thank you.